Good day everyone and welcome to this video tutorial. My name is the phenomenal Dr. Jeremiah. I'm the CEO and co-founder of Unusual Science Tutorial. Now quickly, today we're going to be demystifying chemistry and why many students have issue with chemistry, the basics to understanding chemistry and how you can balance equations and all that. So this is just what we're going to be looking at today. The first thing is writing chemical formulas. Then we're going to be looking at the general principles of writing chemical formulas, the crisscross method, the rules for polyatomic radicals, rules for transition metals, rules for hydrated compounds, general naming principles in chemistry to name any compound at all, balancing chemical equations, and the shortcut method to writing any formula and balancing any equation in chemistry. Because if you don't have proper understanding of balancing equation and writing chemical formulas, you're going to have issue with topics like stoichiometry, electrolysis, all those calculations in chemistry, and even normal chemical questions, because this is the foundation of chemistry and you need it to excel in your whole level exams and what have you. Quickly, without wasting much time, let's just dive into this video right away. I'm going to do yourself good by watching this video from the beginning to the end, because this video is going to be helping you understand chemistry better and excelling in your exam. So let's dive straight into the video.
Breaking news. Are you looking for the right place to prepare for the 2026 JAMB exam? The Unusual Science Tutorial is the best place for you. My name is Mohamed Timtayo, a newly admitted nursing student of the prestigious University of Ibadan. As an ex-student of the Unusual Science Tutorial, I will testify the Unusual Science Tutorial classes are exceptional. And even their free classes are what you get in most paid tutorial classes.
Because they have same angle, it means tension is same. Real jump bomb. They have same angle, it means tension is same. So it means that we have T sine 30 plus T sine 30 equals to 20 meters. The unknown. What is the unknown? What is the unknown? Like in this question now, we have at what speed does it hit the ground? So it means speed is the unknown. There's what we call anomalous expansion at 4 degrees Celsius. At 4 degrees Celsius, volume is minimum, minimum, while density is maximum. Now, the first thing is the core principle. The core principle. Now, it should be shown on your screen right away. A chemical compound must be electrically neutral. This means that the total positive charge from the metal cation must equal the total negative charge from the non-metal or anion or radical. The goal is to reach a net charge of 0. Take for instance, we have a compound like sodium chloride. Sodium chloride. Sodium is positive +1 and chlorine is -1. So the net goal is for this compound to be 0, for this compound to be electrical neutral. That's the basic principle you must know for chemical formulas, that our end goal is having all chemical formulas, all chemical compounds to be equal to 0. So that is the first principle you must take note of, that a chemical compound is electrically neutral. Now, let's quickly dive to the crisscross method because there's no time. The first step is that you must write the symbols side by side. So you must put the positive ion, that's the metal first, and the negative ion, non-metal second. Just like we did in, I think it should be showing now. Sodium is the metal, while chlorine is the non-metal. So this guy is the metal, why this guy is non-metal. Now, once we are done with that, the next step is to write the valency charge number of each ion above the symbol as a superscript. So let's run this again. So if we have sodium and chlorine, so the charge or the valency is +1 and this guy is -1. So how do we know the valency? For those that may be curious, so we have what we call the groups in the periodic table. So you have, according to the whole periodic table, you have 8 groups. Let's just work with that one to avoid confusion. So we have 8 groups. So for instance, now this is group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8, or you can call it group 0. But this is not, the modern periodic table actually is not actually numbered to 18. Transition metals is included, but let's just work with this guy for understanding purposes before we proceed. Now, group 1 metals, group 1 elements are usually metals. We have what we call hydrogen, although hydrogen is not a metal, it's a non-metal, but it's placed in group 1. Then we have helium. Sorry, helium is not in group 2 rather. So we have hydrogen in group 1. Then we have lithium. Then we have sodium. Let's just work with those three for now. You can check out your periodic table. You can check out the periodic table online or somewhere. But I just want to do something. So this group 8 now, we have helium. Why is helium placed in group 8? Because it's a noble gas. Noble gases are those guys here. They're also called group 0 or group 18 according to the modern periodic table. That's X VI. Group 18 according to modern periodic table. But let's just work with group 8 because this one does not include transition metals. Now, helium is here. Then we have what we call lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Yes, fluorine. Then we have neon. Yes. So we have sodium next. Then we have, after sodium, we have magnesium. After magnesium, we have aluminium. Then you have aluminium, silicon, phosphorus, sulfur, chlorine, and argon. These are things you should know as a science student. Know the first 30 elements, to be precise. The first 30 elements, their atomic numbers and everything. Because it's going to be very helpful to balancing equations, writing chemical formulas and all that. Now, please take note that these guys here, their valency is 1. Or their charge is +1. If you want to include the sign. So 1, then these guys here, it's 2. The group 2 elements is 2. Then group 3 is 3. This guy is 4 or 2. Why is it 4 or 2? Now the rule is that these guys, they have one valence electron. What is valence electron? For instance, now we have let's just draw hydrogen now. Hydrogen just have one electron there. That's why it has 1. It's giving the atomic number 1. So it has 1 electron in the neutral state. Now, since hydrogen has 1 electron in the neutral state, what does this tell you? It tells you that the valency of hydrogen is 1. Now, for these guys, they have 2 valence electrons in their compound. So let's look at beryllium, for instance, now. Beryllium, that's Be there. So it's actually, if you number it now, 1, 2, 3, 4. That's the atomic number. It has an atomic number of 4. And the rule is that the K shell, this is the K shell. I didn't plan to do this in this video, but I just feel like K shell, L shell. Now, this K shell has 2 electrons. K shell can only accommodate 2 electrons. Please take note for your concept questions. It can only accommodate 2 electrons. Now, the remaining 2 electrons will now be in the L shell. So we have K shell, L shell, M shell, N shell, and all that. Now, K shell can accommodate 2. The remaining 2 is going to go there. So this beryllium now, if you look at it, it has 2 electrons in this external orbital. So this is called an orbital. So although it has 4, although beryllium is 4, beryllium 4, but it has atomic number of 4, but it has 2 electrons in the valence shell. The valence shell is the last shell. So it means that it is going to have a valency of 2 and not 4, although its atomic number is 4. And to be even smart, is in group 2. So it means that this is in group 2, it's going to have a valency of 2. Then these guys, they have 5 or 3. Now, why are they 5 or 3? Remember, this guy is 8. If you minus 8 from 5, you can get 3. So sometimes they can exhibit 5 or 3. Why these guys can exhibit 6 or 2. And fluorine, they can exhibit 7 or 1. Then neon, it's 0. But let me tell you something about these guys. This from group 4 to group 8. Instead of exhibiting 5, usually they usually exhibit 3, the lower one. Yes, they usually exhibit 3. Because they are usually non-metals. These guys on this side. This group 1, group 2, group 3 are usually metals, especially group 1 and group 2. These guys are borderline, group 4. They are borderlines. They are known as metalloid. Yes, they are known as metalloid. They are in between metals and non-metals. Now, but these guys, they are practically non-metals. They usually take the lesser value. It's actually negative. So we have, for instance, I say 5 minus 8, that's minus 3. So these guys usually have 3. Then these guys usually have 2. Because you can't expect them to take in the valency of 6. So they're going to be having 6 minus 8, that's equals to minus 2. Then the halogens, group 7, they're going to have 7 minus 8 equals to minus 1. Then we have, what's it called? Actually, non-metal usually take this negative sign. Then halogens 8 minus 8 equals to 0. That's why they're actually called group 0. Now, moving on to the next row quickly. You write the valency of each ion above the symbol as a superscript. I've said that earlier. Now, the next one is that you take the number of the charge from the first ion and move it to the bottom right subscript of the second ion. So what does that mean? We have 1 here now. We're going to be moving this 1 below here. Although both of them are both 1, 1. So we're going to be having 1, 1. We're going to be moving, actually it's the one of this guy we're bringing here and the one of this guy here. The next thing that you take the number of the charge. The next thing, do not bring the positive or negative sign down. As I say, I didn't bring the negative or positive sign down, just the numbers. Now, if the numbers can be simplified like 2 or 4, divide them by the smallest number to get this lowest ratio, and a superscript of 1 can never be written. For instance, now, if we want to now combine these guys now, we're going to now have NaCl. We cannot be writing Na1 Cl1 because we have to neglect it. That's what rule 7 is talking about. Now let's try it with another compound. Let's say magnesium chloride. Remember, magnesium is in group 2, like we discussed. So it's going to be having positive 2. Then this guy has negative 1. So how do we write this compound now? We're going to bring the 1 here to this side. Remember, we interchange it. They are going to bring the 2 of magnesium to this side. So we're going to now combine it now. We're going to now be having MgCl2. That's how you always see this compound, MgCl2. That's how all compounds actually came to be. Let's try another one. If you have calcium oxide. Calcium now, calcium is in group 2. That's positive 2. And this guy is in group 6, negative 2. Now, if you combine them, you're going to be getting, if you bring these guys 2 down now, you're going to have 2. If you still bring these guys 2 down, you're going to get 2. So now you're going to be having Ca2O2. But like we said, according to rule 6, we can divide this guy to reduce the lowest term. If we divide 2 of them by 2, we're going to be getting CaO. So it's not CaO2, but CaO, because we can reduce it. So when you have multiples of 2, 4, or 6, or whatsoever, you can reduce it by 2 to get the lowest value. Hope you get. So, but these guys now, we didn't reduce anything. Why? Because this guy has 1, 2. So they are not same. They have 1, 1. So if you divide this one by 2 now, you cannot divide this by 2 because you're going to be having a fraction. Hope you get. So, but when you have, maybe you have, let me use A4x2. You can divide this thing by 2 to give us A2x. Yeah, that's going to be the simplest form. Hope you get. So please just take note of these rules and let's quickly go on to the next one. Now we are done with the general principle and the crisscross method. Now let's move to the rules for polyatomic radicals. Now, what are radicals? Radicals are a group of ions that act as a single unit. For instance, now when you have SO4, 2 minus, that's a radical. When you have OH minus, so you have a group of atoms that act as a single unit with a single charge. So they have a single charge. So let's look at the rules for writing polyatomic radicals. So the first one is that never change the numbers inside the radical itself. Never change the numbers inside the radical itself. And the second one is that if the crisscross method gives a radical a subscript of 2 or more, you must put the radical in brackets before writing the subscript outside. Now, for instance, you have magnesium hydroxide, MgOH. MgOH. Remember our rule, first one says never change the value. Now, this guy is minus OH minus. You must learn some radicals. I'm going to give you some radicals you must master. So this guy is OH minus. It means that this guy is minus 1. Why this guy is plus 2? Remember, magnesium is in group 2. So if you want to combine them, you're going to have 1 is going to come here, 1 from OH, then 2 will come here. So what do you do now? You're going to now be having MgOH. How do you put the 2 now? You have to introduce what we call brackets. So you're going to have MgOH2. That's how you write magnesium hydroxide, because we have to bring the 2 from magnesium down to OH. So we're going to now be having Mg1, although 1 is not included, then OH2. So the next rule quickly states that if the radical only needs a subscript of 1, do not use bracket, like we said in the previous scenario we looked at. Now for transition metals, quickly, that's metals that have variable valency. So you have to learn these ones that are showing on your screen. For instance, iron 2 has a valency of 2, iron 3 has a valency of 3, copper 1 has a valency of 1, copper 2 has a valency of 2, lead 2 has a valency of 2, lead 4. So it depends on the Roman figure that is close to it. That's the valency of the compound. Now, for there's elements that have transition metals that have variable valency. No transition metals exhibit variable valency as one of the key features of a transition metal that differentiates from a normal metal. They have they can exhibit different valency in different compounds. Hope you get. Now, you must master the list of radicals. Like I said, I'm going to give you some. So ammonium, you have NH4 plus, hydroxide OH minus, nitrite NO2 minus, ClO3 minus, ClO minus, HCO3, HSO4 minus, MnO4 minus, Cn minus. So these guys are actually with just a monovalent. So you have MnO4 minus, Cn minus, that's cyanide. Now, even ethanoate is minus 1. But these guys now, they're divalent, carbonate, sulfate, SO3. So they have 2 minus. That what we mean by divalent. So they have the charge on top of it is 2 minus. Then for trivalent, you have phosphate, PO4 3 minus, PO3 3 minus. Then for ferricyanide, you also have 3 minus. So these are the guys you must master. You must master these guys if you want to. We're going to look at some examples quickly. I don't want to just run through these rules before we now move into examples proper. Now, let's move to the next one. So we are done with the rules for polyatomic radicals and transition metals. Now let's quickly go to the rules for hydrated compounds. We'll take general naming rules and we take examples and shortcuts. Now, quickly, for hydrated compounds, these are salts with water molecules trapped in them. So you use a dot to connect the salt and the water. So the first thing you must take note of is that we have to take note of prefix. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 10 is deca. So, for instance, now we have copper 2 sulfate pentahydrate. Now, how do you write this kind of compound? Remember that we said that you have to connect it with dots. You have to connect the water molecule to the compound with dots. So you're going to be having CuSO4 dot. Your dot is very important in writing hydrated compound. Now, how do you know how many water molecules to add? He said pentahydrate, so 5H2O. So pentahydrate. If you look at the next there, we have sodium carbonate decahydrate. So it's going to be Na2CO3.10H2O decahydrate. Now let me quickly say something. Somebody will be like, but in the compound it was written copper 2 sulfate. Where is there no 2? in this copper. Remember I told you guys that you have CuSO4. SO4 now is a radical. It's something you must take note of because it's under divalent radicals. So it is 2 minus. Then copper, what is copper? Copper is plus 2. Plus 2. Remember that is they said copper 2. I told you guys that transition metals exhibit variable valency. Copper can exhibit different valence states. So they wrote copper 2 to tell you that the valency of copper there is 2. So copper 2. So if they write iron 2 now, F3, that means the valency of iron in this compound will now be will be 3. So they wrote copper 2. So it means that we're going to have 2 plus. What we are following? We're going to be having 2 plus and 2 minus. So we're going to bring down your 2 and your 2, which tells us we're going to be having Cu2SO4. Open the bracket. Remember that for radicals, you must open the bracket when you have multiples. But now, like I told you, 2 will cancel out 2. We're going to divide it. It means we're going to be left with 2 divided by 2, 1. 2 divided by 2, 1. So we're going to be left with CuSO4. That's why that 2 didn't show in this CuSO4, because it has been cancelled out when we were forming this particular compound. Before we added the hydrated ion, the hydrated molecule, that's H2 pentahydrate. What we get? So these are very, very easy things. This is something like we've just been going through them and it's very going on smoothly. So see, writing chemical compounds is actually very easy. You just need to know it's just the basics, and that's where many students have challenge. We're going to look at more examples as we proceed, and you're going to master the concept. Now, let's quickly go to the last part of this naming rules, just general naming rules, before we now run to solving questions and doing examples. Now, the last rule is that you must name the metal, then the non-metal ending in "ide". So you have sodium chloride, sodium bromide. Understand? So you are naming a binary compound. It has just two metals, or sorry, it has just 2 atoms. So you're going to be ending in "ide". So sodium chloride, potassium iodide. Understand? So radicals, you name the metal, then the name of the radical. So for instance, now for radicals, I'm going to be having sodium sulfate. That's if you have NaSO4, or for this guy now, copper sulfate. See, they said copper 2 sulfate. So you must first name the metal, then the radical. Then for the next rule, you must include the Roman numerals in the name. So for transition metals, you must include the Roman numerals in the name, because they have variable oxidation state. But for normal compound, normal metals, you don't have to include any variable oxidation state, because they usually have just one stable oxidation state. So, but transition metals, they have variable oxidation states. You must include the Roman numeral in the name. Now, let's quickly run through some examples. I know we have dealt with this topic, and we can now write chemical formulas, write chemical equations, and also balance them properly. And this is going to be a step to your success in chemistry. Let's quickly just do these examples. We have 8 questions on your screen, 8 compounds to write their chemical formulas. Now, what we are going to be doing, I will do 5 of them. We are going to do 3. I'm going to be doing 5. I'll be selecting them randomly. For instance, some of them have similar questions. I'll just pick one of them. Then I'll do 5. Then you do 3. So 3 is going to be your assignment. Just drop it in the comment section below once you are done with this video. Or while you haven't watched the video, just drop the answers. The ones I didn't answer, just drop them in the comment section. I'm going to be going through every comment and marking them. And also, don't forget to like this video, share to your friends that need this video. So the first one there is aluminium oxide. Just take your notes and let's run through this. Aluminium. So write the compound, the element first. Aluminium oxide. So it means we have aluminium and oxygen. Aluminium oxide. So now aluminium is 3 plus. Remember, it's in group 3, or you can say plus 3. Plus 3 is in group 3. Then oxygen is minus 2. It's in group 6. Now, how do you combine these guys now? Normally, I say we are going to interchange it. We are going to bring 2 down here. We are going to bring 3 down close to oxygen. So we are going to be interchanging it. These 2 come down, then this 3 comes down. So what we will now do now, we are going to now be having Al2. If you mash them, we're going to be having Al2O3. And that becomes the chemical formula for aluminium oxide. So you see, it's very, 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 very easy. So we're done with the first one now. Let me just take the second one too, although it looks similar to the first one, but let me just do it. You're going to do 3 actually. So we have calcium and nitrite. So what is nitrite? Nitrogen. So it means the compound has calcium and nitrogen. So what do you do now? Calcium is +2, is in group 2. Then nitrogen, just learn the periodic table, just master it and you're good to go. I hope you are sincerely following because I try to demystify it to the lowest form as possible. Now, nitrogen is -3. I said that these guys usually take the lowest form. Why is in group 5? So I'm going to have 5 minus 8, which gives you -3. So now, although the sign is not relevant anyway for what we are doing. So now we're going to bring 3 there and bring 2. So we're going to mash them now. We're going to be getting calcium nitride. So this is the formula for calcium nitride. So this is the chemical formula Ca3N2. Then let me give this one as an assignment. Let me take it assignment. Okay, let me now take aluminum sulfate. I think they are similar. 3 and 4 are similar. Let me just do aluminum sulfate as an example. The board is getting filled. I hope you can see this section. Aluminum sulfate. Now, sulfate, that should tell you we are talking about something, a radical. Sulfate. So this guy nitrate is also a radical. Go and look for the examples I gave to you. I gave you some radicals to master. So master them. So this guy now is 2 minus. Now aluminium is +3. Remember it's in group 3 and it's +3. So what do you do now? Bring your 2. This guy is one entity. Don't take it and say oxide. No. Sulfate. Sulfate is the radical. So it's taken as one entity and it has one charge. Remember the definition of radicals, that these are this is a group of atoms that carry a single charge. A single charge. So the charge of this radical is -2. So we are bringing 2 down here from our crisscross method. Now 3 for aluminium. So what do? You mash them. You're going to now be getting Al2O, sorry, not O, SO4. Look at it very well. We have 3, so we have to bring our bracket. For radicals, we have to bring the bracket. Why? Because it's all the atoms here that have the 3, not just one entity. If you just come and just write 3 under, you have written another thing entirely. So you must add your bracket to indicate that it's this entity that has the 3. So the chemical formula for aluminum sulfate is Al2SO. So the chemical formula for aluminum sulfate is Al2SO4, open bracket, close bracket, 3. What we get? Now, you must take notes. This is why some people have issue with writing chemical equations, because you don't know how to write out chemical formulas. Now, we are done with this guy. So this is, okay, we are done with this one. This one is an assignment. Then I will solve, let me do 5. I'm going to take 6 as an assignment also. And also 7. So 3, 6, and 7. So let me do question. I've done this one. So let me do 5 and 6. Sorry, 5 and 8. So iron 2 carbonate. I hope you are following. Take your book. If you are not taking your book, aluminium. Is it aluminium? Sorry, we are done aluminium sulfate. Iron 2 carbonate. Now iron, we're going to write Fe. Carbonate, it tells you that we are talking about a radical. Carbonate. It tells you we are talking about a radical. And is this radical complete? No. Go back to your rules. I told you guys that it's CO3 and it's divalent. So it's CO3 2 minus. Hope you get. So now, from the rules, it's 2 minus. Now, this transition method, remember I told you guys that transition methods are going to specify the valence state. Why? Because transition methods have variable valency. So this guys now, it has +2. So what do you now? If you combine both of them, since the charge of this guy is -2, you bring 2 down here, you're going to now be having Fe. So if you now mash them, you're going to be getting Fe2 CO3. Remember, you have to open your bracket and close and add the 2. But remember our rule that when you have multiples of 2, you can reduce them. So if you divide this guy now, what will I be getting as my answer? I'm going to be getting FeCO3. Simple. So it means that my formula is FeCO3. That's for iron 2 carbonate. Very, very simple. So imagine we are iron 3 carbonate. So it means this guy will be plus 3 and we have our minus 2. So it's just the iron 3 that is changing. So if this place, okay, it was iron 3 that is even here itself. Oh, iron 3. But this is for iron 2. So if it's iron 2 carbonate, so it's going to be FeCO3. But for iron 3 now, that's one our initial question. So let's do iron 3. So iron 3 plus 3. So it means that we're going to bring our 2 down from carbonate. We're going to interchange the sign. Remember, the valency rather. Then we're bringing our 3 from iron. So now if you match them, you're going to be getting Fe2 open bracket CO3 3. Is it simple? Yes. Now what's the difference between both of them? The difference is that this one is iron 2, while this guy is iron 3. Hope you get. So you see, this thing is actually very, very easy. So the chemical formula for iron 3 carbonate is this one. Then this for iron 2 carbonate. Now I want to do last one, then we can call it we have done enough for chemical formulas and just move to balancing equations. Now ammonium is NH4+. Remember, you learn those examples and master them. Then phosphate is PO4 3 minus a trivalent. That means that we're going to be interchanging the sign, the valency now. 3 because of the 3 here. Then this one is 1 plus 1. We're going to be bringing 1 here. What do you do now? We're going to combine them. Sorry, mash them. We're going to be having NH4. You're going to open and close the bracket and add 3. You cannot just add 3 anyhow. Then your phosphate, we have just 1 there. You're going to mean you're going to have 4 PO4. Now, I think this is very, very simple because the chemical formula of ammonium phosphate becomes NH4 3 PO4. So we're able to solve 1, 2, 3, 5, and 8. So I think this for 1, this for 2, this for 3, this for 4. Is it 4? Okay, 5. Then this is for 8. So I'm going to solve 1, 2. So just take number 3, number 6, and number 7 as your own assignment to do. And whatsoever you get as your answer, just drop in the comment section. I'm going to be going through the comments and marking your response. Okay, quickly, let's now look at balancing chemical equations now. Now we'll be able to write chemical formulas. You can write out majority of these formulas yourself. Now I want to balance this equation because they are not actually balanced. So balancing chemical equations obey the principle of conservation of mass, which states that matter cannot be destroyed, but is transformed from one form to another. For instance, when we have products, they give us reactants. We don't just have hydrogen loss. Hydrogen does not just disappear into the space. So it just states that mass is always conserved. The number of the mass of the reactants is equal to the mass of the products. So in case you are asked, a balanced chemical equation obeys the law of conservation of mass. Now let's quickly balance this equation. I'm going to be showing you, there's 4 examples here. I'm going to be showing you 4 different methods. So it's going to help you to balance equations faster. So this first method is just what we call the ordinary method, because we want to just look at it with our eyes and just balance it up. So it does not involve any because it's not tedious. Just have 3 atoms there or 3 substances there. So you have H2O, O2, and H2O. Now let's rewrite it here. We're going to have H2 plus oxygen is O2. Now these are things you should know, that when you have a molecule, when you have gases, they exist as molecules, gases. So you have oxygen gas is O2 and not O. You have hydrogen gas, but this is hydrogen atom, but hydrogen molecule or hydrogen gas is H2. These are things you should know. For instance, sometimes we have phosphorus as P4. That's phosphorus molecule. What we get? Now we have chlorine. Please, these are things you should know. If you see chlorine gas in a chemical compound, once I say you should write out the equation yourself. Maybe you are writing WAEC or exams that involve theoretical parts. Chlorine is Cl2 and not Cl. These are things that people don't really understand in chemistry. So when you have molecules, you have Cl2. But what are they called? Metals like sodium now, you cannot have Na2, no, because it's a metal. It exists as solid. What's it called now? Aluminium, magnesium, calcium. You cannot have Ca2. Now, let me quickly say something. Before I proceed. There's what we call, let's use calcium now. Or let's not use calcium. Let's just use C. So if I have C2 and 5 here, what does this mean? So this is coefficient in mathematics, coefficient, and we have subscript. These things are very important for balancing equation. You must take note of it. That's why I think I just have to just explain. I didn't even plan on explaining this stuff now. Now, coefficient, anything can have coefficient. Anything. We can add 2 now to aluminium here. Can add 2 to hydrogen here. Want to balance the equation. But you cannot just manufacture a subscript. It must be part of that molecule or species. For instance, now, I cannot just come and just write Mg2. No. Magnesium does not exist as a molecule. It does not exist as a diatomic molecule. It's only substance like gases, chlorine now, hydrogen. These things are gases. Phosphorus now, P4. So I cannot just come and have Mg2. Why? Because it exists as an atom. It's a metal. Now, this 5 here is coefficient. But I can have 5 magnesium now, depending on how the equation is. But I cannot come and have Mg5. I cannot manipulate the subscript. That's what I want to just show you. But I can manipulate the coefficient. So it means that in this equation now, all these equations, I can only manipulate the coefficient and not the subscript. So we're only touching this coefficient of all of them. Coefficient is the number before the atom or the molecule or the species. So you get, if I had 5 here now, I manipulate, but I cannot manipulate and go and add 2 here. No. If I add 2 to H2O here, it becomes another compound, and that's hydrogen peroxide. So I cannot just come from nowhere and just manufacture and just add a subscript. I'm only manipulating the coefficient. I think that is clear. So I wanted to just show you that you must take note of all this stuff when balancing chemical equations. Now back to our equation. So let's complete. You have H2O. So now this one, once you just can just call it, I call it ordinary method. Just view it and just add the coefficient. So now hydrogen. How many hydrogen do we have on the left hand side? Hydrogen is 2. So now please take note. When balancing chemical equations, a chemical equation. So hydrogen now, we have 2 hydrogen atoms here. This is a molecule. I think I have to just say this. Now, if you have O2, this means 1 oxygen molecule. Oxygen molecule. Please, please follow. Don't be lost. Now, but this means 2 oxygen atoms. Oxygen atoms. Well, that's 1 hydrogen oxygen molecule. But 2 oxygen atoms. Why? Because we have O. It is bonded to form a molecule. So we have 2 oxygen atoms. But this O2 now is 1 oxygen molecule. Please take note. So what does this mean now? I have 2 hydrogen atoms on the left hand side. Then how many hydrogen atoms do I have on the right hand side? I also have 2. So you can probably say hydrogen is balanced. For now, is balanced. And let's go to oxygen. It means oxygen is going to be the defining factor if we have to balance something here. Now, oxygen is also 2 atoms on the left hand side. But on the right hand side is 1 atom. Now, it means this equation is not balanced. Because according to the law of conservation of mass, the atoms on the left hand side must be equal to the atoms on the right hand side. the atoms here must equal the atoms here. Since we have 2 atoms of oxygen and 1 atom of oxygen on the right hand side, then it's not balanced. So what are we going to do now? We are going to manipulate this equation. Now, since we have 2 oxygen atoms, it means if I introduce 2 here, oxygen becomes 2 atoms also. I have 2 oxygen atoms here. If I introduce 2, I'm going to have 2 oxygen atoms. So I'm going to now have 2, 2. So let me change it to 2, 2. 2 atoms. But now something dramatic happened. As I added 2 here now, I'm now having 4 hydrogen. 4 hydrogen. 4 hydrogen. But on this side, I'm having 2 hydrogen. What can I do? Because hydrogen is standing alone on this side, it means I can actually, what I just did is possible. But for this kind of equations, or the other equations, this may not really be possible just viewing with your mere eyes. You have to cancel and cancel, clean it and come again. But why this, what I'm doing now is going to be possible is because I have just hydrogen standing alone here. What will I do? Since I have 4 atoms now of hydrogen, I'll just have to add 2 here. 2, that's what I remembered. 2 times 2, 4. 4 hydrogen atoms. So it's not because maybe you have 3 H2 now. Know that you can say 2 plus 2 is still 4. So in case you say, how did I get 4? You're not going to say 3 plus 2 is 5. No, it's not plus, so it's times. It's multiplication. So 2 times 2, 4. So that's 2H2. What does 2H2 mean? It means H2 plus H2. And what does H2 means? HH plus HH. So it means I have 1, 2, 3, 4. So I have 4 hydrogen atoms here. So I have 4 hydrogen atoms now. When I added 2 to balance oxygen, no oxygen is balanced now. 2 oxygen atoms, 2 oxygen atoms. Now, 4 hydrogen atoms, I added 2 here and it becomes 4 hydrogen atoms. 2 times 2, 2 times 2, 4. So what does that tell you? It means that this equation is balanced. So to balance this equation up, we have to just add 2 here. I have to add 2 here, and it's balanced. So 2, 2, with my eyes, I balanced it without stressing myself. But for complicated ones like this now, we have to now introduce another method. So I thought I'm going to show you 4 different methods in this class. Now let's move to the next one. This question 2 is very, very crucial. You have to follow. Please follow. I want to show you something. Now, I want to give you a methodology. So, first thing, when you have equations like this that probably have radicals, what do? You first balance the metal. When you have balanced the metal, you balance the radical. Now, when you are done balancing the radical, I already taught radical in this video. Just scroll back in case you missed it. Now, when you have balanced radical, you balance hydrogen. And when you have done balancing hydrogen, you balance oxygen for me. So, this is my second method I'm showing you today. Now, it could also work here. Can also work here. But this one is just a normal equation. You don't have metals here. So, let's just forget about it. Now, this guy, aluminium H2SO4. Let me write it here. Al plus H2SO4 gives you let me add space. Al2SO4 3 plus H2. Now, how do I balance this equation? I said metals first. Now, the only metal here is aluminium. What do? On the left hand side, we have 1 aluminium atom. On the right hand side, we have 2 atoms of aluminium. So what do? I think I will have to introduce 2 here. Remember I told you guys that you can only manipulate the coefficient, you cannot manipulate the subscript. I can only manipulate the coefficient. So I can only add values to the coefficients in front of all the species here, all the compounds and atoms here. Hope you get. So I'm going to just add 2 to aluminium because we have 2 atoms of aluminium in this compound. You understand? But aluminium as a metal But aluminum as a metal on its own or as an atom exhibits as aluminum atom. So I can only add coefficient to the front to have maybe 2 aluminum atoms and all that. Now, this guy now, if I had 2, I'm going to be having 2 moles of aluminum atoms. I also have 2 aluminum atoms here. So it means that aluminum is balanced. So we are done with our first guy here, metal. Now, let's quickly move to radical. What is radical? I told you guys that things like NO3, SO4, OH, I gave you radicals to memorize. So just memorize those radicals. So SO4 now is the radical in this equation. So we have it on the left hand side and on the right hand side. And it obeys the principle of conservation of mass because it appears on both sides. Now, what do we do? SO4. On this side, we have, let me use another hint. So we have 1 is invisible 1. So it means I have 1 SO4 here. You know, remember it's a radical, so they are joined together. Now, but on this side, remember there's a 3 here. It means I have 3 SO4. Hope you are following. Remember we're balancing radical next. So I have 3 SO4 here. What do? I just have to come here and add 3 to balance my SO4. So I now have 3 SO4. I have 3 SO4, 3 SO4. So from there now, I have 3. I hope you are seeing how it's flowing. Well, I balanced aluminum, I balanced the radical. That's SO4. So the next thing now is hydrogen. What do? Why do I even have to balance hydrogen next now? Because anything I do to hydrogen will also affect oxygen. I can't actually balance any of them. Anyone I love, but I like hydrogen. Why? Because it's standing alone. So there's a tactic you always use. When something is standing alone, you just balance it easily. Why? Because if I have 6 here, it means that if I add 6 here, sorry, I have 3H2, that's 6 atoms of hydrogen here. If I add anything to balance this guy here, it does not affect any other thing here. So it means that hydrogen is balanced automatically. So since I have 6 atoms of hydrogen here, if I add 3 here, this guy becomes 6 also. 3 times 2, 6, 3 times 2, 6. So it means hydrogen is balanced. What is left? Oxygen. Is oxygen balanced? Let's see. Normally it should be balanced. Why? Because I've added a lot of atoms. But let's see if it's still balanced. If it's not balanced, we'll balance it up. So this guy now, we have 3 O oxygen. 3 times 4. Remember this 4? Now, there's a reason why I always say add a bracket when you're adding writing radicals. NO3. If I now maybe I'm adding a compound like maybe calcium now, that is 2 plus, and this guy now is minus 1. If I'm combining both of them, I'm going to have 1 will come here and 2. Remember our method of forming chemical formulas. Then never forget it. So if I combine them now, I'm going to be having CaNO3, but I cannot just add 2. I have to bring in brackets and write CaNO3 too. So what does that tell you? CaNO3, that's calcium nitrate. But where is it? I'm trying to explain something. Okay, yeah, we have SO4 here. SO4. These 3 actually affect only oxygen. But these 2 affect all the things in the bracket. That's the reason why we added the 2. Because it affects the radical. This radical already comes with 4 under oxygen. So this subscript affects only oxygen. But if I write 2, it affects all atoms here. That's a simple idea you should know. So it means that in this equation now, I have 4 here under oxygen. And there's also a 3 that is covering all, which one will I use now? There's a 3 that is covering all the compounds here. So this compound as a whole now, I have 3 in front of all of them. So it means that 3 is affecting nitrogen, it's affecting sulfur, it's affecting oxygen. So what does that tell you? It means that the number of atoms of oxygen now is 3 times 4. For oxygen, 3 times 4 on the right hand side. Now on the left hand side, let's see what's there. I have 4 oxygen atoms there. Normally that's for sulfate is SO4. So there must be 4. That's the radical formula, SO4. I think to learn the radicals formula for some common example you are going to see in your exam mostly. So SO4. Now there's 4 oxygen atoms here. Hope you are following. There's 4 oxygen atoms here now. 4 times 3. Obviously, they both give me the same thing. 12. 12, 12. So it means oxygen is balanced. Oxygen is balanced. Hydrogen is balanced. The radical is balanced. Metal is balanced. So obviously, we can now say this equation is balanced. What did we add? We added 2 to balance aluminium. We started with metal. Then we added 3. So I add 3 here. Then we added 3 to hydrogen to balance hydrogen. So from this equation now, you can see that our equation is balanced. It's just like number 1 anyway. We're just trying to just like use our eyes, just put coefficients, put figures, balance the atoms. You get. That's number 1 and number 2. But number 1 is much easier because you just have simple atoms and molecules there. But for number 2 now, we have complicated ones that have radicals. So I just gave you a shortcut: metal, radical, hydrogen, oxygen. You can only do oxygen before hydrogen, but anyone, just let's do hydrogen before oxygen. Now, number 3 is where people have issue with. It's a complicated equation. You understand? It's a complicated equation. So we're going to be introducing another method. Although this method can actually work for all of them. I call it the algebraic method or the shortcut method. Anyone want to call it the algebraic method or shortcut method? So let's quickly run. Now, what we're going to be doing next, I hope you are following. Hope you are jotting it down. Now, if you are enjoying the video, just say something in the comment section. Let others know that this video is worth it, is worth watching, and let you also like the video so that YouTube can recommend it to others. I hope you are enjoying the video actually. So I want to just simplify it to the barest minimum so you can understand how to do this thing. This is actually the basics of chemistry. If you can get this balancing equation, doing stoichiometry and every other calculation you are always having issue with, it's going to be easier with this. Hope you get. Now, the first element, we have different elements here. Let's pick them out. We have carbon, we have hydrogen, we have oxygen. So all through now, we have carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. So what do we do? We're going to write out the elements or atoms there: carbon, hydrogen, then oxygen. Now, carbon, we have 4 carbon here and we have 1 carbon here. So what do we write? Since we have 4 carbon, we're going to say 4A. Remember that in coefficient and subscript, I've explained this thing before. For instance, now I have 2H2. So it means that I have 4 atoms of hydrogen. Come back here now. I have A here now. A is standing for a number, for a figure. So I have maybe A here. It's supposed to maybe like 2 or 3, a number. But now I'm replacing with letter because I want to solve algebra, mathematics. So A times 4 is 4A. So just like 2 times 2, that gave you 4. A times A is 4A equals to X times 1. There's nothing in front of, like there's no subscript behind carbon. So I have X times 1, which gives you X. Come to hydrogen now. I have 10 hydrogen times A. It means I have 10A. 10A. How many hydrogen is on this side? 2 times Y. This gives you 2Y. It's not difficult at all. This is actually the simplest and the fastest because you may be giving complicated equations. Just use this algebraic method. Oxygen. Where is oxygen? 2B. 2 times B. Then oxygen on this side, we have 2. Okay, oxygen on this side is complicated. Why? Because we have 2 oxygen. So what do? There's a plus sign here, right? So I'm going to first write the first oxygen. I have 2 times X. 2X plus 1 oxygen. 1 times 1. Sorry, 1 times Y. That's Y. So I'll be able to form my algebraic equation from introducing letters. That's what algebra means in mathematics. I introduce letters so I can get a figure for these different letters represented here. Now, since I have 4a equals to x, now there's a simple method I want to, because some people now, when they get here, they now become confused. What do I do? Which of the compound here or molecules here is complicated? You agree with me that in this equation, the complex compound is C4H10. So I'm going to make A equal to 1 because of C4H10. We're going to make A equal to 1. So we're going to say let A equal to 1 because C4H10 is the complicated compound in this equation. So if A equals to 1, then it means that if I have 4, according to mathematics, so we're going to do mathematics now. 4, I'm going to replace A with 1. 4, 1 equals to x. Bracket means multiplication. So 4 times 1, 4. So it means 4 equals to x. So it means that x equal to 4. A equal to 1. Let's write it somewhere. A equal to 1. A equal to 1. X equals to 4. Now, I'm still left with B and Y. So what do I do? So, but I can look for Y from this place. If I make A equal to 1, remember A equals to 1, the complicated compound. So if I make A equal to 1, you're going to have 10, 1 equal to 2y. 10, 1 equals to 2y. So I'm going to have 10 equals to 2y. From there, I have y equals to 10 divided by 2 because I have to make y stand alone. So I'm going to divide both sides by 2. When you have multiplication, because 2y means 2 times y. So do not bring y to that side, just divide both sides by 2. So I can cancel out 2 from this side. So when I'm done with that, I'm going to get 5. So it means that y equals to 5. So I have a equals to 1, y equals to 5. I'm left with one thing, which is B, and B only appears in oxygen. So what do I do now? I'm going to replace, I know x and y now. X is 1, x is 4, y is 5. I'm going to replace this equation now with x and y. So what am I going to do? I'm going to have 2b. I just hope you are following. 2b. 2, what is x? X is 4. What is y? Y is 5. So I'm going to say 2b. 2 times 4 is what? 8. 8 plus 5 is 13. So it means I have 2b equals to 13. From there, b equals to 13 divided by 2, which gives you 6.5. 6.5, or you can just leave it as 13 over 2. So now, you may be like, how will 6.5 be in my equation? Don't worry, there's no big deal at all. Or just leave it as 13 over 2 self, because it's going to be easier for us. So now, we're going to be imputing all these values we have gotten. X equals to 13 over 2. Sorry, b equals to 13 over 2. I'm going to impute all of them into this equation now. We're going to impute it into this equation and balance it up. Because there's a fraction, we have to do something to make it balanced. So let's rewrite this equation now. So when you have an equation like this, C4H10, so A is what? 1. So you know that 1 is not written in mathematics or physics. So just leave it like that. B is 13 over 2. We're going to write 13 over 2, O2. What is CO2? X is 4. I'm going to have 4 CO2 plus, what is hydrogen? Sorry, I say hydrogen. What is Y? 5. I'm going to have 5 H2O. Now, when you have a fraction like this, a complex, a fraction, you're going to just multiply all the terms by 2. Because if I multiply this place by 2 now, 2 is going to cancel 2. I'm going to be left with 13. Once you have a fraction, you just multiply the whole equation by that, the denominator. This is denominator, this is numerator. On top, numerator, denominator. So if I multiply this whole equation by 2 now, what am I going to be getting? I'm going to be getting 2C4H10 plus 13O2. This 2 is gone now because I've multiplied the whole equation by 2. 2 times 4, 8. 8 CO2. 2 times 5, 10. I have 10 H2O. So the balanced equation is 24H10 plus 13O2 plus 10H2O. So what do I do now? Let's come and write it here again as we have been doing. So I have 2, I have 13, then I have 8, then I have 10. You see how the algebraic method works? It's very, very simple actually. To show you how simple it is, let me quickly solve this first equation like that now. So imagine now you have H2 plus O2. So I have H2. So I have H2, just to add letters to the front of all the different species. Then I have CH2O. So if you look at it now, on the left hand side, hydrogen, we have just hydrogen and oxygen in this equation. So H now, we're going to be getting A equals to 2 times A is 2A. Equals to, how many hydrogen is here? 2 times C, 2C. Now if I come to oxygen, I have 2 times B, 2B. But I have 1 times C times 1 oxygen, which gives you C. So it means that 2A equals to 2C. So let's first equate the first one and find something. I was saying that you can make A equals to 1. Which one is, not all of them are actually complex, but let's just make A equals to 1. So if I make A equals to 1, or let's make C equals to 1. If you make C equals to 1, you're going to get the same thing. But let's just do it. This, I think H2O is more complex here, like we did in the previous one. C4H10 was more complex. So let's do it like that. C equals to 1. So we're going to have 2A equals to 2, 1. We are replacing C with 1 now. So that's 2A equals to 2. Then from there, A equals to 2 divided by 2 equals to 1. So it means that A equals to 1, C equals to 1. We said let's make C equals to 1 because of this one is more complex than the other molecules. Now, A equals to 1, C equals to 1. So we are left with just B. So what do I do to B now? You see this one is, that's why I said you can just manipulate that one. But you can still use the algebraic method. You still get the same answer. So 2B equals to 2C. What do you do now? I'm going to replace, I know C equals to 1. So C equals to 1. So what is it now? B equals to, if I divide both sides by 2 to let B stand alone, I'm going to get 1 over 2. So from there now, if I write out this equation and replace these different letters with this, what I've gotten so far, what do I get? I'm going to get A equals to 1, it's going to stand alone. O2 stand alone. Okay, sorry. B was here. So B is 1 over 2. So we said C equals to 1. And we said let's C equals to 1. So we're not going to write anything there. So now to remove the fraction, like we said, you multiply everything by 2 to remove the fraction. If I multiply everything by 2, I'm going to now have 2H2. If I multiply this side by 2 now, it's going to cancel out. Nothing's going to be there. If I multiply this side by 2, because I want to remove the fraction, I'm going to have 2. So if I clean this thing off now, I'm going to be getting 2H2 plus O2 plus 2H2O. Does it not correlate with this guy? 2H2 plus O2 plus 2H2O. You see that algebraic method, if you want to use your eyes to just manipulate it, anyone you want to do, you're going to get the same answer. But the reason I just wanted to show you the easier method, ordinary method, because this one was not a complicated equation. You understand? These two. Same thing, if you still use algebraic method, it's going to still work for this guy. It's actually the same thing. Just have to just look a note. We have aluminium, we have hydrogen, we have sulfur and oxygen. We have 4 atoms here. We are going to balance everything. Just draw out the equation like that. When you have aluminium on this side, so I'm going to write it 1 aluminium. Sorry, if you put A now, A equals to, maybe you make this one C, 2C for aluminium. Come like that for the other metals or atoms, and you are good to go. It's very, very simple. I don't know. Let me know in the comment section if the algebraic method is very simple. And which one will you be using? Although I've not done the last one, let me do the last one. You are going to now decide which one you want to be using. Although people will choose the last one. Let's see. Let's see why. Now, this last one is very critical. Let me tell you why. This is an MCQ question. It's a JAMB question. So I'm going to read out the question and we're going to be using, let me tell you what the method means. We're going to be using the answer, the options to determine the answer. We're not going to solve anything. Just by looking at the options, I'm going to get my answer. It's actually the fastest for MCQ. We're not writing theoretical exams. And you have to now start showing the method they are using, algebraic method. I think you have to write out algebraic method, or you have to start saying atoms of oxygen. So anyone you want to use. But this guy now, we're going to just be using the answer. So I didn't write out the option. Let me read the options out here. So the question reads actually the balance equation representing the, you're going to show on your screen. The balance equation representing the reaction between copper and dilute Charles 155 acid is ACU, as we added A to it, just like this method, this third method of algebraic method. So they added it for you already. So BHNO3 to give you SCuNO32 plus YH2O plus 2NO. What are the values of A, B, X, and Y respectively in the equation? So what do? I want to simply go to the options and use to determine my answer. How do I do that? So the first option there says A equals to 3843. Let me see if that option is correct. This means copper is 3. Now, what do you do in this kind of question? Copper is standing alone. I'm going to use copper to determine the answer. Simple, fast, very fast. I'll use copper to determine the answer. So, copper is 3 there. Since copper is 3, and they say A, that means A is 3. So, let me go to X, ox. Ox there is, they said ox is 4. Copper is 3 and it's appearing on ox side. That's where X is, this one. So I have copper here and copper here. So I'm going to just look at these two guys. Forget about every other thing. So copper is 3. Now go to that side. They now said copper is 4. The first option has 3:8 4:3. I know that answer is wrong because we have just one copper atom here. Anything I add here is going to affect it. If I add 3 here, it's going to be 3 here. Why? Because copper is there's no subscript here. So if I add 3 now, if I say they say they added 3 in the first one, 3. But why are you adding 4 here? It means it's not balanced. So it means that option is wrong. I'm using the answer to the options to determine the answer now. So it means that this one is wrong because I added 3 and 4. So this one is wrong. Now let's go to option B. They added 3. Okay. 3:8 3:4. It looks like it makes sense because there's 3. Just look at the one that is just a single element. Because if you add 3 here, you have to add 3 here. Because there's no other copper here, there's no other copper here. Hope you get. So it means that this one is making sense. Let's forget about the other guys. Let's just go to the next option and look at it. Now, option C also makes sense. They say they added 1, 4, 1. No, we're just looking at these two guys for now. So it makes sense. So this one can make sense too. Then they added 4. Then option C is automatically wrong because they're adding 4, 1. Okay. C can make sense. Yes, can make sense. 4, 4, 1. Okay. Now we already know that B is wrong. So what do I do next? A is wrong. What do I do next? 3, 3. So if I added 3, what is B there? 8. So if I added 3, 3 here, now let me go and check if hydrogen is balanced. So if I'm adding because there's no letter here, so it means that okay, hydrogen is not standing alone there. I'm looking for something that is standing alone, that is not included in any other one. So now I want to use hydrogen now as the case study, next case study, because I think I have just one hydrogen here. So if they say they added 8, that's 8 is B here. 8. Now, what will now be hydrogen here? Remember that I'm multiplying. So if I add 4 times 2 gives me 8. So it means that Y is the last thing there. No, it is A ratio B ratio X ratio Y. So it means that Y is 4. So it means that this guy is wrong. Y is 1 here. Y is 4 here. But Y is not 8. So it means that it is wrong. So it means that option B is correct. Why? Because when I imputed 8 here and I imputed 4 here, I'm getting 8 atoms of hydrogen, 8 atoms of hydrogen also. But if I impute 4 here, I'm going to get 4 atoms of hydrogen. But here, if I include, 4 also, I'm going to get 8 atoms of hydrogen. Hope you get. So your first task You should just first check, okay, which one is even making sense from copper. Then you now move to another atom, hydrogen. From there, you're already getting your answer. You don't need to even go to nitrogen and oxygen. Because from there, now when you see that, okay, 8. Since I remove option A already, we have just B, C, and D. Then I added 8 here, and I'm getting 8 oxygen atom. Okay, I'm trying all the options. So since I tried this one and it makes sense, is my answer. But if I saw these two options first and I put 4, I got 4 oxygen hydrogen atoms, and I come here now and I'm seeing the next thing. You know that we have Y. Hydrogen is Y here. Let's neglect this guy because they are just too voluminous. We're having nitrogen here, oxygen. We have to start adding. Since hydrogen is just alone here, so let's just use hydrogen. You have to be very smart. This is smart work. So I have if you put 4 now, 4, and I say I'm coming to put 4. It is not balanced, right? Because 4 times 2 is going to give me 8. Hope you get. So it has to be 8 and 4. Now if I come here, it's automatically wrong because here now they have 1 and 1. Cannot be correct. It has to be 4, 8 and 4. So you see, this method just like using the options. When you give an MCQ question, give you the option. I'm going to be giving you a question. It's going to be shown on your screen. So just try to attempt it and see what your answer is going to be. So this is how to just balance equations. These are different methods. First one, the ordinary method. Just look at it. Second one, can call it the complex of the ordinary method. Then this one, algebraic method. This one, we're using the options to determine the answer. So it's very fast actually. So let me know the method you're going to be using in the comment section. Although your exam is going to mostly be in this format with MCQ. So let me know the method. I said that many persons will use MCQ. Let's see. Just let me know in the comment section which one would you be using. Which of the methods do you prefer? Which one do you think is faster? I'm going to give you an assignment now. It's going to show on your screen. You can just drop your answer in the comment section and also let me know which method you'll be using. That's going to be all for this video. I hope you enjoyed this video. Let me know in the comment section by dropping something for me. I want to see your comment. I'm going to be there and interact with you and engage with you. Like I've always been saying on this YouTube channel, don't forget to keep reading till you become a book. I can't wait to see you celebrated very soon.